Alright, let's talk about the Singleton pattern. This is probably the most asked about design pattern in interviews, and for good reason. It's simple to explain, but tricky to implement correctly, especially when multithreading is involved. Let's break it down step by step. So imagine you are building a large application. You have a database connection pool, a configuration manager, and a logger. Now, what happens if different parts of your code each create their own instance of the database connection pool? You'd have multiple pools fighting for connections. Your configuration manager might have stale values. Your logger might write to different files. That's the core problem. You need exactly one instance of these resources, shared across your entire application. And that's what Singleton solves. The solution is elegant. You make the constructor private, so nobody can call new on your class from outside. Then you store the single instance as a static field inside the class itself. And finally, you expose a public static method, usually called getInstance, that returns that one instance. The beauty of this is lazy initialization. The instance isn't created until someone actually asks for it. Think of it like a country's president. There's only one at any time. No matter who asks, they get the same person. The office itself ensures there's only one holder. Let's look at the key components. First, the Singleton class itself, which holds everything. Inside it, you have a static instance field. This is where the one and only instance lives. The constructor is private, so external code can't create instances. And then there's the public getInstance method, which is the only door into this class. If the instance doesn't exist yet, it creates it. If it already exists, it just returns it. Simple, clean, and controlled. Let's walk through the Java implementation. Notice the instance field is marked volatile. This is critical for thread safety. Without volatile, one thread might see a partially constructed object. The constructor is private, so you can't do new Singleton from outside. The real magic is in getInstance. It uses double-checked locking. First, it checks if instance is null without synchronizing, which is fast for the common case. Only if it's null does it enter the synchronized block, then checks again. This prevents two threads from both creating instances. This is the thread-safe lazy Singleton that interviewers love to see. Let's talk trade-offs. On the plus side, you get controlled access to the sole instance. No rogue instances floating around. It reduces namespace pollution compared to global variables. And it supports lazy initialization, so you only create the instance when you actually need it. But here's the thing, and interviewers love to hear this. Singleton violates the single responsibility principle because the class manages its own lifecycle and its actual business logic. It can mask bad design by becoming a fancy global variable. And it makes unit testing really hard because you can't easily swap it out with a mock. That's why many modern frameworks prefer dependency injection over raw singletons. So when should you use Singleton? When you absolutely need exactly one instance, like a configuration manager or a thread pool. When a global access point makes sense, and you need lazy initialization. Classic examples are loggers, database connection pools, and app-wide caches. If you are interested in related patterns, check out Factory Method and Builder, which are also creational patterns but tackle different problems. That's the Singleton pattern. Understand the double-checked locking in Java, and the __new___ trick in Python, and you'll nail this in any interview.